Welcome everyone and good morning. So happy to see you brave people here on the first session. 3 years ago, I knew that the Azure way to do infrastructure as code was to create Azure Resource Manager templates or ARM templates. But I didn't like them. I thought they were hard to read. I didn't understand the structure, and I thought it was impossible to find good documentation. So I did a responsible thing. I told the new guy to be in charge of creating the ARM templates in my project. In this session, I'm going to describe my journey of becoming to like ARM templates and actually think that they are really powerful. If you pay attention, you will learn how to create ARM templates that are easy to read, easy to understand, and easy to maintain. So a few weeks passed, and the new guy was complaining a lot. He thought it was hard to create the ARM templates. He couldn't find good documentation, and the syntax would change all the time. So I thought to myself that in the next project, I would create the ARM templates and see if I could find solutions to all the problems that the new guy was complaining about. So I looked into the documentation for ARM template, and I found out that they are really much like the architecture drawing of a house. Instead of the different rooms, they contain a list of Azure resources that you would like to have eventually, including how each resource is configured. So when you deploy your ARM templates to Azure for the first time, the Azure Resource Manager will look at the templates and look at what you have in Azure, which is nothing at this point, and then it will deploy all the templates, no, all the resources in the templates. If you make a change, like add a new resource, and you deploy that templates, the Azure Resource Manager will look at what you have in Azure and in your templates, and then just deploy the new resource that you added. So only the change that you made to the template since last time gets deployed. So to give you an example on how an ARM template can look like, I will create one that creates a storage account where you can store files, queues, and data tables. So I will start from scratch, and I will create a skeleton for an ARM template by using the snippet in Visual Studio Code, by using the ARM exclamation mark snippet, like this. So I go to the resources and I create a new object. And now I can ask Visual Studio Code what I need to type. So the type, or the resource type, is important. Type, storage. Storage, no, not that one. So Microsoft storage accounts. So that was the hard part of this demo. Then I need to specify something else, the API version. So as you can see, I get really great help in Visual Studio. And usually I go with the latest possible API version. So now that I specified the resource type and API version, I kind of have a contract. So I can ask Visual Studio Code, what can I write? So all of these files is possible to write. But not all of them are mandatory. So I can check here. I need to specify name, SKU, kind, and location. So I will start with the name. And here I can type anything I want. I can type Tech Lab Storage 99, something like that. And then I will do the location, because almost all resources in Azure need a location. I'll go with West Europe, which is kind of close to Sweden. So now there was something else, like 2 other things, SKU and kind. So kind first, and that is kind of to specify which kind of storage account I will create. So storage version 2 is the most versatile one that I use the most. And then the SKU. And I know that this is an object, and I can check. The name is required. So here I get a list of the different names for the SKU, and I will choose this one, standard local redundant storage, which is the cheapest one. So maybe I will not use that one for production, or when you want like global replication or something. So this is how you deploy your template. So you can deploy this to Azure by running a PowerShell script like this. New Azure Resource Group deployment. And then I specify a resource group name and a template file. So I think we can try to deploy this. I'll call that PowerShell script. Now I see what happens if I write something that already exists. This one already was existing, so I will select another one. So it was complaining that the storage account the name was already occupied. So the name will need to be unique. And by the way, the files from the demo, I will give you a link so you can download them on GitHub, so you don't have to remember everything that I do here. So it takes a little while, but now I can see deploy was succeeded, and I was deploying to this one, TechLab Dev 1. So let's look at, let's see. TechLab Dev 1. Here we have our storage account. You can see that one already was existing, but this is the new one. You can see it's in West Europe. It is local redundant storage, just as we wanted. Okay, so let's continue. So we have an ARM template, and we can use that to deploy to Azure to create our storage account. But at work, we have several different environments: development, test, staging, and production. And as you saw, if I try to deploy the same ARM template, Azure will complain that this storage account already exists. So I need some way to slightly change the name of the storage account so that I can have one in development, one in test, one in staging, and one in production. After a bit of looking, I realized that parameters are a great way to do this. So they are a lot like a parameter in C# or in other language. You can send in a parameter, and that will kind of modify the behavior of the function. So in the first function, we don't have a parameter. We have a hard-coded value for the storage account name. But in the second function, we have a parameter, and we can pass different names, and that will create different storage accounts. But if you have parameters and you have different environments, it's a good thing to have parameter files. So you can bunch, like you put all the values of your parameters into one file, a parameter file, and then you specify that file when you deploy it to development first, and then you deploy the same ARM template to production, but then you're using the production parameter file. So let's look at how you can do this with ARM templates. So I'm trying to make the new stuff a little bit bolder. Maybe you can see, and in the scroll bar I have the green thing marking what's new since the last demo. So I have a new parameter. It's of type string, and I have a default value of standard local redundant storage. So if I don't specify a value, I will get this one. And I also specify allowed values. So standard local redundant storage, standard zone redundant storage, and so standard U redundant storage. So I can specify which values are valid, but in this case, I'm also limiting the possible choices. So I say that it's not possible to choose a premium version of a storage account here because we don't need that. And I have a description for my parameter that we will see later. I have location, and the default value we get from calling the function resource group that returns information about the current resource group, and return the location from that function. I have a storage name, and that has a min length and a max length. So we can look at the name that we used before, and that has a min length of 3 and a max length of 24. So here I help the user to specify a valid name for the storage account. So I can, using Visual Studio Code, I can see the description. I could right-click and go to definition. I could press F2 and I could rename it. So now it's called storage name 22 there as well. And go to like find usages and stuff like that. So it's quite good tooling, really. So to specify the name, of course, I call the parameters functions and I specify the name of the parameter. Same thing for the location, parameters, location, and parameters storage SKU for the name of the SKU, which means stock keeping unit. And that is kind of a way to specify important attributes for a resource in Azure. So you will find kind and SKU for other resources as well. So let's see. I mean, if you wanted to introduce your own parameter for something, you could select and right-click and then press extract parameter or variable. So I will select parameter and I will say storage kind. So I got kind of a reference to the new parameter here. I press F12 and I can see that we got a new parameter of type string and the default value is storage version 2. So you should really think this was a little bit silly example because you don't want the user to change the storage kind. So you have, when you introduce new parameters, think about what do you want the users to be able to change and what should be like fixed and standard. The more parameters, the harder it will be to understand what's going on. So flexibility over readability. You have to decide what's best for you. So now that I have my new parameter, I can right-click and select generate parameters file. And that will generate a parameter file that contains all the parameters that I have. So I can see that I have storage version 2 for the storage kind, standard LRS. For the location, I didn't really specify a default or a kind of a good default value. So I need to replace this or remove it, doesn't matter. And the storage name I need to define as well. So before you came, I prepared different parameter files for development. So here I have standard local redundant storage for development, and the name is TechLab Storage Dev. For production, I'm using U redundant storage, and the storage name is TechLab Storage Prod. My team name is called TechLab. So there's a way to visualize this in Visual Studio Code. So there's a plugin that I can call by using this I. Right now, it only contains storage account, so it's not super visible, but you can also use this when you have many resources, and then it will show like dependencies and stuff. So I can specify which parameter that I want to use. So I will begin with the development. And now I can see, if I click here, I can see that the name is TechLab Storage Dev, like I specified in the parameter file. And the kind is storage version 2. And the SKU name is standard local redundant storage. So it seems to work. Our parameter file for development. And now just going to show you parameter file for production. So selecting the name TechLab Storage Prod and SKU name standard local geo-redundant storage. So it seems it's a nice way to visualize what kind of resources you have in your ARM template, and also to see that you got the parameter files correct. So after a while, we realized that we wanted to have a website or an app service for this. So we created an app service, but before we can do that, we needed to have an app service plan. So you can think of an app service plan as a server where you can host many app services or websites. And I came up with a naming scheme because I didn't want to specify a parameter for the name of the storage account, the app service and app service plan. I came up with a naming scheme where all the resources will have the name TechLab and the name of the environment. So having the same name for the same as for storage account was a problem, as you saw before. But if you have different resource types, you can have the same name. So here you can see from the Azure portal, I have the same name for TechLab Dev for all my resources, but they have different resource types and different icons. So this works fine. So this is something you can do if it works for you, or you can define some other naming scheme. But I don't think you should have parameters for all your resources, because that will be hard to maintain. So what I need to do using pseudocode, so don't try to run this. I will show you in an ARM template later. But I will create the storage account using TechLab and then the name of the environment, and then I will create the app service plan with the same name, and then I will create the app service. And then I will get the resource ID. And a resource ID is kind of a unique identifier in Azure. It's a long string. It begins with the subscription and ends with the resource type and the resource name. But if you look at this code, you can see that I add TechLab and the environment 5 times. So if this was C# code, I will refactor it at once. But since it was ARM, I had to look a little bit for a solution. And I realized that the concept of variables exists in ARM template as well. So it's same thing, and you can use ARM variables to decrease code duplication and also to introduce a good variable name instead of comments, but you can have comments too. So here I introduced the variable resource name, where I add TechLab and the name of the environment, and I use that in the 5 places. But now I see that I called the get resource ID 2 times, so I introduce another variable for that, resource ID. I call the get resource ID function, and I use the value in 2 different places. So let's look at how you can do this in an ARM template. I have a new parameter. It's called app service plan SKU. Default value is F1, but you could also specify B1, B1, and S1. I have an environment. Instead of specifying the name of the resources, I specify an environment, and I'll calculate the resource name by adding TechLab and the name of the environment. So as I showed you in the picture before, all the resources will have the same name. And I calculate this server farm resource ID by calling the resource ID function with the resource type for app service plan. So Microsoft.web/server farms. You will see this a few times later. And then as a second parameter, the name of the resource that we calculated here. So you can reference the variable that you defined before. So when I create the storage account, I will get the name from the variable resource name. And when I create the app service plan, I will use the same name from the resource name. I will specify an API version and a resource type for the app service plan. I will get the location from the parameter location, and I will get the SKU from the new parameter app service plan SKU. Let's see, we have a description for that as well. Here you can see that I have added comments. So you could have single line comments, or you could have multi-line comments. So depending on which tool you are using, you might have to add an extra parameter to that. Like for Azure CLI, for instance, you need to specify the -j parameter, because believe it or not, parameters are not a part of the JSON standard. It's part of the JSON C standard. So it depends on how you want to validate your files. So I get the name by calling the variable resource name. We have the resource type Microsoft.web/sites for resource type. I have an API version, and I get the location from the parameters location. And here you can see that this resource depends on the app service plan, which means that Azure needs to create the app service plan first, and then we can create the app service. So this depends on is a way to define in which order Azure needs to create the different resources. Because if we want to create, if Azure tries to create the app service first, that is referring to the app service plan, that will cause an error. And in the properties, we specify the app service plan for this app service by using the variable server farm resource ID that we calculated before. Okay, let's continue. So we continued developing our application, and we stored our data inside a table storage that resides in the storage account that we created. But in order for this to work, we must create an application setting called table URI, and that must contain the address to the table storage. So I guess I could do this by hand, like manually create this setting every time I create a new environment. But I didn't want to do that. I wanted everything to be deployed automatically with ARM templates. So I needed to find a way to create this application setting and then set the value. And I found that there's a resource function that will give me the runtime state of a Azure resource. And for the storage account, the runtime states includes the address of the table storage. So what I needed to do in the ARM template was to create a new application setting with the name table URI and set the value to the value returned by the reference function. So let's look at how you can do this in ARM templates. So here you can see we have the app service here, and inside that app service we are specifying a child resource. So if you remember, we have resources on the top level, but under each resource we can have a child resource that usually is kind of dependent or related to the parent resource. So we're creating a new resource with the resource type config and the name app setting. And we got an API version. And inside properties, I specify that I want a new application setting called table URI. And I will call the reference function with the resource type for app service plan and the name of the resource. And when the return value from the reference function, I will get primary endpoints and then table. And here you can say that this app settings depends on the app service above, and that app service depended on the app service plan. So here you have a clear kind of dependency chain. We need to create the app service plan first, then the app service, and then the app service setting. But you might wonder, how did you know that you were supposed to take primary endpoints and then table? Well, I didn't at first. You could look it up in the documentation, or you could just try it out yourself. So the output is a way to send values from the ARM template deployment. So it could be that you're using the value in a PowerShell script later, or it could be that you're using it in Azure DevOps for something else. So we're specifying that we need a new output called storage with the type object. It could be many things. Same as we could have parameters with different types: arrays, bools, ints, objects, secure objects, secure strings, and strings. So if you look in the documentation, you will find the different values for these. But right now we're using objects. If I selected secure object, we wouldn't see the output, and that would kind of defeat the purpose. So a secure object for things that are secret, that you don't want to display in the Azure portal, for instance. So I'm calling the reference function with the same parameters as we did before. And the goal is to see what is the runtime state of the storage account. So let's see what happens when we deploy this. As you can see, this is actually the same things that I have on my GitHub page. So you can find that the demo for the fourth demo is in the fourth catalog for 4.reference. So I have dev deploy, and I specify the resource group name, TechLab Dev4, the template file, and the templates parameter file for development. So I deploy this to Azure. It takes a little while, but it's quite fast. So here you can see the deployment was successful. These are the parameters. These are the outputs. We have a storage. It's of type object. And we got some network stuff, some encryption stuff. And here we have the primer endpoints. And here we have the table address to the table storage. So you can do this with any type of resource that you would like to look at. If you look at the GitHub page that's for this session, you will also see that there is not only the reference functions, but also list functions starting with list, so like list keys, list SaaS accounts, and such. So that's another way to get the runtime state of an Azure function or Azure resource. So let's continue. So I was listening to a talk from a guy in our cloud team, and he told us that we should try to keep the costs in Azure down. And one of the ways we could do this was to use multiple app services for each app service plan. So the app service plan is the resource that costs a lot of money, and if possible, we want to share app service plan. So in our current setup, we have one app service plan for each environment. So one for tests, one for development, one for staging, and one for production. And we're paying for 4 app service plan. That is the resource that costs money. But if we could share app service plans in the test environments, we would pay for 4 app service plans instead of 2. Or the contrary, 2 instead of 4. So half the price. But how can you do this in Azure? So I realized that there is a condition feature that you can use if you want to not deploy a resource during certain circumstances that I can use. So I will not create a new app service plan for the development environment and not for the test environment, not for the staging environment. And there's also an if function that you can use to kind of modify the configuration for the app service so that the development app service points to the test app service plan. So in Pseudocode, what we want to try is this. I introduce new parameters, new app service plan that is a Boolean. If it's true, then we will create an app service plan like we did before. If it's false, we will use an existing app service plan, and then we will need to specify the app service plan name as the last parameter. I compute the app service plan name by looking at the new app service plan. That was a Boolean, right? If that was true, we will use the resource name as we did before. And if it's false, we will use the app service plan name that we used as a parameter. When it comes to creating the app service plan, I will check if the new app service plan is true. If it is, we will create the app service plan. If it's false, we will not create that. And when it comes to creating the app service, we will use the calculated computed app service plan name. So let's see how you can do this with ARM templates. So I have 2 new parameters, or 3 actually. Create new app service plan. This is of type Boolean. Default value is true, so we will If we don't specify something, we will create a new app service plan. But if it's false, we need to specify the name of the existing app service plan in this parameter. It's a type string. And we also need to specify which resource group that app service plan exists in. So, for instance, for like development, we will point to the test app service plan that is in another resource group. We will have the same variable resource name as we had before, but we'll also create a few new variables. So we'll create a new app service plan that is the same as the parameter, but we convert it into a Boolean value, which will make it easier to work with later. And we compute the name of the app service plan by looking at this new variable. If that is true, we will use the resource name as we did before. But if it's false, not like that. If it's false, we will use the parameter app service plan name. Same thing with the resource group. If create new app service plan is true, we will use the current resource group. And if it's false, we will create the supplied app service plan resource group. When we create the app service plan, we get the name from the computed app service plan from the variable that we created before. And here, this is like maybe the most important part. Condition. If a condition is evaluated true, then we will create the resource. If it's evaluated to false, we will not create it. So here we are looking at the variable, but it could be some kind of a comparison, like if this equals something or something is greater than something else, we could use that as well. So we use the variable new app service plan to determine if we want to create this resource or not. When we create the app service, we depend on the app service plan that we calculated before. And when we specify the server the app service plan, we go to the resource group, resource type for app service plan, and the name of the app service plan. So let's look at the different parameter files. We have development, and we will not create a new app service plan here, but instead we will use the app service plan in the resource group TechLab Test 5, and the name is TechLab Test 5. So we have a test parameter file as well. Here we will create a new app service plan, and the environment name is test 5. So let's try to deploy this. So we have two deploy functions, one dev that will deploy to the development environment, and one test that will deploy to the test environment. Ooh. So I will begin with deploying the test environment because we need to create the app service plan, right? So that seemed successful, and then we can deploy the development environment. that was also successful. So we'll go to the resource group Tech Lab Test 5. So here we can see the storage accounts, the app service plan, and app service. So nothing kind of strange here, but we can look at the app service plan and look at the apps that are using this app service plan. And we can see that besides from this one that is in the same resource group, we also have a Tech Lab Dev 5 that is in the resource group Tech Lab Dev 5. So it seems like our goal was successful. We are using this app service plan for 2 and possibly more app services. So now we are reducing the cost in half, basically. So what else do we have? We continued developing our application and everything was fine. We were really happy. But then we got to the security review that is performed by our application security team. And they said, no, this is a critical application and you need to have the highest possible uptime. So you need to have multiple app services and app service plan and put them in different locations. So if there is a problem in Azure, let's say that there's a power outage or an earthquake or something in West Europe, then the application will continue in North Europe. And we put this application behind a load balancer, and that will kind of switch, like send the traffic to the app service that is working at the moment. So I guess I could copy and paste my ARM templates, but I didn't want to do that because it would make the ARM template twice as big almost, and it would be harder to maintain it. Like if I wanted to change a setting, I would have to do it in 2 places, and if I forgot and just did it once, it will be a problem. So I wanted to find a way that would create similar resources without having to specify it like twice in the ARM templates. And I found that there's a feature called copy that would create resources that are similar, but in the same deployment. So what I decided to do was this. I have, instead of a string location, I have locations. So I can specify West Europe and North Europe, for instance, if these are the locations that I want to have. And then I create 3 arrays. And the purpose of these 3 arrays is to make it easier to create the resources later. So it's a little bit more complexity in the beginning, but I think overall this is a better solution than having the complexity in all the places where I create the resources. So I have a resource names array, which is of the same size as the location, and I have this resource IDs for the service, app service plans, and app services in 2 arrays as well. So I create a for loop and I kind of loop over the different locations, and I set the value for resource names to be tech lab and then the name of the environment and then the name of the location that I send in as a parameter. And I get the current index from copy index. So if location is West Europe, then the resource names will be techlab dev-West Europe. So the thing for the plan resource IDs is the same thing. I call the function getResourceID with the resource type for app service plan, and then the name of the resource that I calculated just before. So if a location is West Europe, the resource ID will begin with subscription, and then the resource type for app service plan, and then the name of the app service plan. When it comes to creating the app service plan and the app service, I create a new for loop. So I get the name for the app service plan by looking at the resource names array that we created before. And when I create the app service, I also get the name from resource names, and I specify the current index by copy index. And I get the resource IDs from the plan resource IDs and site resource IDs. And here too, I specify the current index with copy index. So let's look at how you can do this with ARM templates. So in version 1 that you can look at on the GitHub, I did the same thing without the new variables. So you can compare if which one you like. But we're looking at the one with variables. So we have a new parameter, locations. It's of type array, and the default value is the current resource group. For the variables, the resource name is the same as before, and we specify the copy feature, and we say that we want to have array with the name resource names. And the size of that should be the same size as our locations. So we could have like 1 location or 2 or possibly more in the future. And the value of each instance or item in the array would be the resource name that we calculated here, TechLab dev, for instance, and then the location, and we specify the current index like this. So the plan resource ID is the same thing. We create a new array. We have the same length as the locations, and the value for each item in this array is the value returned by the resource ID function with the resource type of the app service plan and the name of the app service plan. And again, we get the current index by calling the copy index. So that would return 0 the first time, 1 the second time, and so on, if we have more than 2 locations. Same thing with site resource IDs. An array with the name site resource IDs. We have the same length as the locations, and same thing with the resource IDs. But we specify the resource type for the app service instead of the app service plan. For the storage account, we get the location from the first location, or the first item in the locations array. But because we just need one storage account, and we put that in the first location. When it comes to creating the app service plan, we specify the copy feature with the name app service plan copy. And we will have the same length as the locations. So we will have one app service plan for every location. We get the name from the resource names array, and the current index we get by calling copy index. Let's see what kind of help we get. Returns the current index of an iteration loop. This function is always used with a copy object. Seems reasonable, right? And we get the location from the locations parameter array. When it comes to creating the app service, we do this almost the same thing. We have a copy with the name app service copy, and again, the same length as the locations. And this one depends on the app service plan copy. So we are saying that you should be ready with all the app service plans before you start with the app services. And when we specify the app service plan for the app service, we are using the variable plan resource IDs that we specified before. And again, we get the index by calling the copy index. Yes. So do we have any questions at this point? I use 3, and you will find all of them in the GitHub page. So just look there, and I will specify it. And they are listed in the order of importance. So the first one is like a must-have, and the second one is like generating the parameters, and the third one is like visualizing. So you don't really need. They are nice to have, but the first one you must have. Yes. No, it's no, not really. We can try. It will display the resources. So it works better on simple templates, but you can see the resources and but it's not perfect for advanced scenarios. Something else? Yeah. You can do like everything with PowerShell, but so I guess yeah, with PowerShell you can, or you can tear down from the Azure portal if that's what you want to do. So, but not. Yeah, you can. Yes, I mean you could set no. You can, but I would not recommend that way. So I would say find a way to do it in Azure CLI or in PowerShell. Something else? No. Let's continue. So after working with ARM templates for a few years in different projects, I came up with a few guidelines that I try to follow. So creating a good ARM template is like an artist creating a piece of art. The artist must be good at using the different tools and know when to use each tool. So I try to spend time learning the different features of ARM templates so that I am good at using them and I know when to use the copy function and the variables and the parameters, when they make sense and when they just add noise. Getting the ARM template to run is just the first step. If you want a good ARM template, you must look at it and see, is there any way that I can change it so it becomes better, more beautiful? Refactor it. Maybe you can add comments. Maybe you can introduce a new feature, like a variable that you didn't use before, but only use the ones that make sense and makes the template better. When you create a new project, try to create the ARM template as early as possible. So don't try to create the resources in the Azure portal, but create the ARM template and then deploy it to Azure to create the resources. So if you have an ARM template that is up to date and you're working on a task that requires a new configuration setting, then it's quite easy to just update the ARM template, add a new line, for instance. But if you don't have it, then it becomes a big task in the end to create the ARM template. So these are the things that you need to do. You should go to my GitHub page, bit.ly/Svetug-arm. And there you can find all the demos that I talked about today and more resources like sources of documentation, how to use deployment scripts to run PowerShell code, and how to use user-defined functions to decrease code duplication and increase readability. You can send me an email or message on Twitter, but most important of all, use the tools that you learned today to write good ARM templates, but make sure that they are easy to read, easy to understand, and easy to maintain. My name is Nils Hedström. Thank you for listening.